Hello everybody, welcome back. Had a bunch of questions about the rapid pressurization and why that was needed, why would I do that with these. There's a lot to do with diving and going into depth and different atmospheres and pressurization. Every 30 feet you go down, air volume decreases by half. So in a nutshell, the reason I do this is to find out if we have any impurities or air bubbles in the plastic. So when these are printed, I print them at 100% infill, which means there shouldn't be any gaps. I print slow and a few other tactics to try to make sure everything just gets done well with no air bubbles. There's no way for me to know if there's an air bubble unless I actually cause something to cause that air bubble to show itself. So what I'm going to do is do a rapid pressurization. I'll take these down to about 130, 150 feet worth of pressure, so 40, 50 meters. What's going to happen if I do that very, very quickly, the air bubble will shrink rapidly and should cause a fracture or a weak spot. And then by pressurizing quickly, that can actually cause that to actually crack and break. So it'll expand very, very quick. So I have a pile of parts here that we're going to go through. I'm going to put those into a container, and then they will move over to the pressurization chamber. This is just a special piece of equipment I have rigged up to be able to simulate those depths. It just uses compressed air, just a small amount of compressed air, and water, and then that'll actually cause the part then to simulate being down that deep. Anyhow, I'll get this set and we'll get that test started. Okay, I've now loaded all the parts into this bucket. The bucket just helps you get in and out of the pressure chamber, which has been preloaded with water. I need to minimize the amount of water that's in the chamber so that I'm just putting very little air. This water doesn't compress. I just got to compress a small amount of air to put the weight on the water. All these small parts I just put into a baggie. It won't really matter here. If there's any air left in the baggie, it'll get compressed really quick and easy, but it'll still put the same weight and pressure onto parts. Same with the small ones here. So I'll close these up, and we'll get this moved over to the chamber. All right, let's get this loaded. If the chamber was to have a leak, get compromised, whatever, having less air to escape is, think of it as smaller explosion. You don't care about a firecracker, but a stick of dynamite. Here we have 50 psi, rapid. Take it up one more time. Rest. Decompressed. And we'll get this opened up and we'll take a look at what happened to the parts. All right. I already loosened all these things. We're not going to go through every part, but just want to give you an idea of what we're looking at here, and if anything grossly happened, we will know right away. The parts floated out, but I guess I should have used a sealed bag, but that doesn't really matter. These all look intact. Our weight. Body caps show no cratering or cracking, but I will look at these in far greater detail off the video. All the bars and arms look okay. Well, there you have it. All the parts survived. 2 simulated 40-meter dives in rapid succession. If the air bubbles were going to cause problems, or if there was an air bubble that was going to cause problems, it should have reared its head when we did that. Everything looks good. I did a cursory check, but I'll definitely be touching and feeling each piece in this lot to make sure that nothing is fragile, brittle, or making any cracking sounds. I'll tear it apart and look if that is the case to see what happened, but I would say this was a successful batch.